What happens when the world's most powerful man-made force meets its deepest natural abyss? Nuclear weapons, embodiments of human ingenuity and harbingers of destruction, harness the energy of atomic nuclei to unleash explosive power unlike anything else crafted by human hands. Their detonations can obliterate cities, reshape landscapes, and emit energy measured in megatons of TNT. Now, shift focus from the skies to the abyss. The Mariana Trench. Plunging to depths exceeding 36,000 feet, it's a world submerged in perpetual darkness, where the weight of the ocean above exerts a pressure over 1,000 times greater than that at sea level. What would occur if these two extremes were brought together? Imagine a scenario where a nuclear bomb is detonated in this deepest pit of the ocean. The juxtaposition of immense power above and the crushing depths below sets the stage for a thought experiment of epic proportions. Imagine the clash of these titans of power and depth. Dive deeper into the shadows of the earth where sunlight dares not reach. Here, at the very threshold of human exploration, lies the Mariana Trench. It's not just another part of our ocean, it is a grand, mysterious void, the deepest of all oceanic trenches. Picture a chasm so profound that if you were to invert Mount Everest and plunge it into this trench, its peak would still be over a mile underwater. The Mariana Trench is a crescent-shaped scar in the Earth's crust, located in the western Pacific Ocean east of the Mariana Islands. This underwater canyon descends nearly 7 miles, reaching approximately 11 kilometers below the ocean's surface. At these depths, the pressure is an unimaginable 8 tons per square inch, over 1,000 times the standard atmospheric pressure at sea level. To put that in perspective, it's akin to having about 50 jumbo jets piled on top of you. In this extreme environment, temperatures hover near freezing. The chilly waters range from just 1 to 4 degrees Celsius, creating a setting few creatures can endure. Yet despite these harsh conditions, life finds a way. Unique species adapted to the cold and the crushing pressure thrive in this abyssal zone, hinting at the resilience and adaptability of life. The geology of the trench is equally fascinating. It is part of a subduction zone where two of Earth's tectonic plates collide. The Pacific Plate is forced under the smaller Mariana Plate, diving into the Earth's mantle, creating seismic activity that shapes not only the trench itself, but also the surrounding seabed. This geological activity suggests that the Mariana Trench is not static. It's dynamic, constantly reshaped by the forces of our planet. This alien-like environment, shrouded in eternal darkness, holds secrets more profound than its depths. Now let us understand the beast of human creation, the nuclear bomb. A nuclear bomb operates on the principles of nuclear fission or fusion, two processes that unleash vast amounts of energy from within the atom. In fission bombs, heavy atomic nuclei split into lighter nuclei, releasing energy, while fusion bombs work by forcing lighter atomic nuclei to merge into heavier ones, also releasing energy but to a much greater extent. The moment a nuclear bomb detonates, it releases an unimaginable amount of energy almost instantaneously. The core of the bomb reaches temperatures comparable to the interior of the sun, and this intense heat generates a massive fireball. This fireball radiates outward, producing a shock wave that can obliterate virtually anything in its path. The initial blast wave is followed by a powerful gust of wind, further extending the radius of destruction. Simultaneously, the explosion emits intense thermal radiation, causing extensive fires and severe burns over a wide area. This is compounded by the release of ionizing radiation, which can have lethal immediate and long-term effects on living organisms. The iconic mushroom cloud that forms as the fireball ascends is not just a symbol of nuclear power but also a carrier of radioactive fallout which can contaminate air, water, and soil for miles. With such catastrophic power, the detonation of a nuclear bomb is a fearsome event. Pressure in the Mariana Trench is an unimaginable force on its own. Delving into the depths of the Mariana Trench, one encounters pressures that defy human comprehension. At nearly 36,000 feet below sea level, this abyss holds pressures exceeding 1,000 times the atmospheric pressure experienced at sea level. In more relatable terms, imagine the weight of an elephant balanced on a postage stamp, then multiply that scenario by about 1,000. Now, let's introduce a nuclear bomb into this extreme environment. On the surface, when a nuclear bomb detonates, it releases a colossal amount of energy in the form of light, heat, and a shockwave. This explosion results from the uncontrolled release of nuclear energy, causing a rapid expansion of air and energy that we see as the iconic mushroom cloud. But what happens when such a force meets the crushing pressures of the Mariana Trench? The first thing to consider is the immediate containment of the explosion by the surrounding water. Water is significantly denser than air, thus it absorbs energy much more efficiently. This means that the initial blast wave from a nuclear explosion would be stifled almost immediately by the immense water pressure, which acts as a colossal barrier, absorbing and redistributing the energy. Moreover, the high pressure and cold temperature at these depths would significantly alter the behavior of the explosion. Under such conditions, the heat and light from the explosion would be quickly absorbed and dissipated, preventing them from traveling far. The shockwave, typically devastating over great distances in air, would be compacted into a much smaller range, potentially limiting the immediate physical destruction to a relatively small area around the detonation point. This containment effect of water pressure could also impact the release and distribution of radioactive materials. Normally, a nuclear explosion disperses radioactive particles over a wide area. However, in the depths of the Mariana Trench, these materials might be more contained, settling quickly onto the ocean floor or possibly being absorbed into the water column. Under such pressure, even the formidable might of a nuclear explosion could be challenged. The delicate balance of the deep-sea ecosystem faces a hypothetical threat. Imagine, if you will, a nuclear bomb detonating in the depths of the Mariana Trench. The immediate aftermath of such an explosion would not just be a spectacle of unfathomable energy, but a cascade of environmental repercussions. Firstly, the shockwaves generated by the explosion would be immensely powerful. These waves would travel through the water, potentially causing significant disruption to the marine environment. The intense pressure and heat could instantly annihilate nearby marine life and alter the physical structure of the seabed. Furthermore, there's the looming threat of radiation. While much of the radioactive material would likely be contained by the immense pressure of the deep ocean, some could still leak into the surrounding waters. This leakage could lead to radioactive contamination, which would be detrimental not only to marine organisms but could also enter the broader marine food chain, affecting species far removed from the site of the explosion. The unique and often little understood creatures inhabiting the deep sea would face unprecedented risks. Many of these species are adapted to specific environmental conditions and could not withstand the drastic changes in their habitat caused by such an explosion. The loss of these species could have unknown effects on the ecological balance of the deep sea environment. The repercussions of such an event could extend far beyond the immediate blast zone. The potential for long-lasting environmental damage underlines the importance of safeguarding our planet's most mysterious and extreme habitats. What theoretical outcomes can we predict if the unthinkable were to happen? Imagine, if you will, a nuclear bomb detonating at the deepest point on Earth, the Mariana Trench. This scenario, while highly unlikely, opens a fascinating dialogue between the forces of nature and human-made technologies. Firstly, the extreme pressure at such depths, about 8 tons per square inch, would significantly contain the blast of a nuclear explosion. Unlike a nuclear detonation on the surface where the blast radius expands rapidly, the overwhelming pressure underwater compresses the explosion, limiting its immediate physical impact. This containment, however, does not mean the effects are any less significant. The dynamics of the explosion would also be radically different. Water, with its high density compared to air, would absorb a tremendous amount of energy. This absorption could result in less atmospheric fallout than a surface explosion, but the thermal shock waves and intense radiation could devastate marine life in the vicinity. The immediate area around the explosion would likely become an uninhabitable zone for a considerable period, impacting ecosystems that are already poorly understood. Moreover, the environmental consequences could be profound. The disturbance could potentially release toxic substances from the seabed, such as methane hydrates or radioactive materials, which could then circulate through ocean currents, affecting global marine environments. This brings us to another critical point: the uncertainty of it all. The deep ocean is a frontier as mysterious and unexplored as the surface of distant planets. Predicting the exact outcomes of such an event involves a degree of speculation based on what we currently know about nuclear physics and deep-sea environments. While the detonation of a nuclear bomb in the Mariana Trench remains a theoretical scenario, it compels us to think about the interplay of natural forces and human technology. This thought experiment not only highlights potential risks, but also underscores the need for continued exploration and understanding of our planet's most hidden depths. Today we ventured into a profound thought experiment. Our journey took us deep into the Mariana Trench, pairing it with the devastating force of a nuclear bomb. We explored the potential physical effects, environmental impacts, and the theoretical outcomes of such an extreme event. Through this exploration, we underscored the critical importance of responsible scientific inquiry and the careful stewardship of Earth's most mysterious and extreme environments. Though it remains a hypothesis, this scenario urges us to respect and protect the unknown depths of our planet.